Good morning, everybody. We're going to go ahead and look at the warm-ups for today's stuff on Wednesday. So go through these 7 problems that they got here. Hopefully this will set us up for some success on today's assignment. Today we're just going to go ahead and do just kind of a step back, work on problems that have been in the last couple days. So we'll look at the first couple ones, talk about mutually exclusive events. They cannot happen at the same time. So probability of choosing a queen or an ace, because they can't happen at the same. There's no queen and ace. So you have 4 queens, 4 aces, total of 52 cards. Add those guys together, we got 8 out of 52. Second one, roll a 6-sided number cube, probability of rolling a 3 or a 4. So that's 2 positive outcomes out of 6 on our 6-sided die. So remember, mutually exclusive events, they cannot happen at the same time. Non-mutually exclusive, the overlapping events. These are the guys that we have to add the 2 individual events and then subtract the overlapping event. So for the first one, a face card or a heart. Since there are face cards that are hearts, we'll start with the face cards first. We have 12 face cards. You have 13 hearts. And you have 3 face cards that are hearts. So if you remember, it's probability of A plus probability of B minus the probability of our AND equals our OR. So I have 12 over 52, 13 over 52, subtract that overlapping, and we get 22 out of 52. Same idea as we get to number 4, we're just dealing with the 6-sided number cube. So on 4, we got 1 out of 6, probability of rolling a 1. Probability of rolling an odd number, there's 3 of them. Subtracting away our probability of the overlapping, the 1 that is odd, and we get 3 out of 6. Alright, so if we look down at our independent events down at the bottom, and we've got the formula there for you. We're going to go ahead and multiply those compound events. So if we look at the first one, there's a total of 11 apples in the basket. Chance that we get both are yellow if we pick 2 of them, if I replace the first apple. So I got a 3 out of 11 chance. I pull out that apple, it's yellow, I take it, I put it back in. I'm right back to another 3 out of 11. So we got 9 out of 121. Number 6, first apple is red. So I got 6 red apples. I pull it out, I put it back in. I still have 11 apples in there. Now the second one is green. 2 green apples. So next situation, if we look down at our dependent events, this last one, still dealing with these apples, but now we are not replacing. So whatever I pick, the first one, my second choice is now dependent on what I picked. So the probability that I pick a red apple, 11 apples, 6 of them are red. I pulled that out. That guy is no longer there. So if I look, I got red, 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 green, green, pulled out the first one. That guy is now gone. All right. I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 apples left. All right. Which chance of getting the green one? There's 2 of those. I still multiply, so that part doesn't change. All right. But if you notice, my denominator has gone down because I've taken that red apple that I picked originally. I've taken that. I have not replaced it, so we only have 10 apples left. Once again, if you guys got questions on this stuff, shoot me emails. Take a picture of what your work is. It makes it easier for me to go through and kind of help you guys. Hope everybody's doing well, and we'll talk to you soon.